Okay, so problem number 4 is from 2012, and it was question number 4. And once again, we're working with two proportions. So a survey organization conducted telephone interviews from 2008 in which 1,009 randomly selected adults in the United States responded to the following question. At the present time, do you think television commercials are an effective way to promote a new product? Of the 1,009 adults surveyed, 676 responded yes. In 2007, 622 of the 1,020 randomly selected adults in the United States have responded yes to the same question. Do the data provide convincing evidence that the proportion of adults in the United States who would respond yes to the question changed from 2007 to 2008? Okay, so first off, we're talking about proportions. So I know I'm working about proportions. I didn't mention anything about a confidence interval. So I'm not worried. I don't think it's an interval. So I believe this is going to be a hypothesis test. I have two different proportions. I have 2007, and I have 622 over 1,020. So that's 1 p hat. And then for 2008, I have 2008, which 676 over 1,009. And I called those p hat 1 and p hat 2. And my null hypothesis where the two proportions are equal, because that's what we always assume status quo, that they're equal. And since they said, does it provide, they changed. Change doesn't tell me a direction, so that means I'm going to go with a not equal here. I must define them. P1 is true population proportion of adults who believe commercials are effective in 2007 versus the same thing, but in 2008. Conditions. I have two independent random samples. Please notice I combined independent and random together here. And they're given 1,020 in 2007 and then a sample of 1,009 in 2008. Technically, you do not need to include that, but it is good information. Again, here I said two independent random samples, so technically I wouldn't have had to include this. But it's reasonable to assume that the samples are independent, as the responses in 2007 should not impact those in 2008. That does seem reasonable. So if you broke this apart, you always need to make sure you address independence either together or separately. And then we need to make sure that each sample is large enough. So we have to divide each one by 0.1, and we get, that's not large enough. We have to make sure that it's less than 10% of the population. So divided by 0.1, we get 1,090. We know that there's more than 1,090 adults in the U.S. And divided by 0.1, and we know that there's 10,000 more than 10,200 adults in the U.S. in 2007. So both of those were satisfied. That was fairly easy. Okay. Here they tell me 676 in 2008. Yeah, in 2008, 676. I guess I have these labeled incorrectly, and I apologize for that. In 2008, 676, and boy, that's a mess. These labels here are incorrect. I apologize for that. 2008, 676 is greater than 10. The 1,000, and then we subtract and we go, okay, 333 is also greater than 10. In 2007, 622 was greater than 10. 1,020 minus that, so we're also greater than 10 here. So basically, we are large enough. Unfortunately, I switched my proportions. Please don't do that. That's horrible that I did that. Anyway, so I need to calculate my proportions. So I have 676 divided by 1,009. So 67%. Again, this should have been my 2008 value. And then I have 622 divided by 1,020, and this should have been my 2007 value. When I plug them in, first off, we have to pool, because anytime you pool, the only time you pool is when you work with two proportions. So I pool when I have two proportions, and in this case, a two proportion hypothesis test is the only time you pool. You do not pool on a two proportion confidence interval, only on a two proportion hypothesis test. And the reason you do that is because the claim here is they were equal. And so because they're equal, we go, hey, if we combine the proportions together, we'll have a better estimate. So when I combine them together, the 2008 with the 2007, I end up getting a combined proportion of 0.6397. And that would be my best estimate because I combined everything together. So that's what's going to go in the denominator here. All right, so now I'm going to subtract my two proportions, which unfortunately I went 2008 minus 2007. I did not mean to do that. So stats, test. It is a two proportion z-test. And in this case, we had 622. Oh, stats, test, two proportion z-test, 622 out of 1,020. And we also had 676 over 1,009. We said they were interested in not equal, and we need to go ahead and put a calculate on that. And so I end up with getting a z-score of negative 2.8256. Now please notice I put them two times. And the reason I did two times is because of this not equal. So make sure that when you write this down, you have a not equal. We ended up with 0.0048. 0.0048 is less than alpha. We reject the null. Our p-value is 0.0048. We reject the null. There is sufficient evidence that alpha equal 0.05 to suggest that the true population difference in the proportion of adults who believe commercials are effective changed from 2007 to 2008. Simplified to answer their question, the proportion of adults who believe commercials are effective changed. All right. It's really good to give a synopsis answer. Not always required, but you should always give the conclusion the way we have it formatted, and then you really should give a brief synopsis. What did you find? In this case, we found that there was a difference. It was statistically different. There was a change. Again, I apologize for switching 2007 and 2008. I hope that didn't confuse too horribly. Sorry about that.